Okay, here's our third free response problem from some 2016 practice that we have. We have no calculator now in this guy. So the first two calculators came in handy. One good thing about these non-calculators is you're not going to be expected to do any crazy integrations or derivatives, so hopefully it won't be too bad. All right, classic. You're given the graph with straight line segments or semicircles of f, which is going to prove to be the derivative of some other function. They're going to tell us, yeah, down here they tell us that g is the integral of f, so that means f is the derivative of g. But for this first part, it just says find the average rate of change of f. Guys, if you ever see average rate of change of a function and they give you the picture or they give you the function, it is strictly just 7th grade slope. So we need the average rate of change between 5, x equals 5, and x equals 0. So we have the point -5, 0, and the point 0, 2. So that is the 7th grade slope. All we have to do is 2 minus 0 over 0 minus -5. And of course that is just 2 over 5. And that is all she wrote. We just picked up. Now granted, that's probably only going to be 1 point, but that's probably the easiest point on the whole exam. We're going to skip right down to part B now. Let g be the function where g is the integral from -1 to x of f of t. So basically g is going to start gathering area at -1 and gather up area as it moves out in the positive direction, or in a different way it would, going backwards, if they said find, for example, g of -2, because you're starting at -1 and going backwards, even though it's above the x-axis, g of -2 would be a negative number. So stuff above the x-axis counts negative going backwards, and the stuff below would count as positive. But we don't have to worry about that yet, because what does it say? It says find the x-coordinate of each point of inflection of the graph of g. All right, well, the first thing I want to write is, because the definition of g is the integral of f, we want to say g prime is equal to f. Okay, so if you integrate f to get g, you take the derivative of g to get f. And that implies that the second derivative of g is f prime. So in other words, you just took the derivative of g prime to get g double prime, you take the derivative of f to get f prime. So because they're asking about points of inflection of g, we're looking about when does g double prime change signs. That's how you find inflection points, when the second derivative changes signs. Now, many times this year I've talked about how you find points of inflection at the extrema of the first derivative. So if you just remember that, the extrema of the first derivative of g is the extrema of f, and that's right here at x equals -3, and here's the other extreme of the max when x is 0. So all we have to do is write x equals -3 and x equals 0 are the two inflection points. And we'd probably want to describe those differently and say x equals -3 is an inflection point. I'm just going to abbreviate here, because g prime, which equals f, changes from, let's see, at -3, we go from decreasing to increasing. Now, that means the same as saying g double prime changes sign. The slope of g prime, which is g double prime, changes from negative to positive. And then we can do the same thing at x equals 0, and that's where our slope of f, which is the slope of g prime. So we can say this is an inflection point because g prime, which equals f, changes from increasing to decreasing at x equals 0. So there you go. You could maybe just try to say the inflection points occur at the extrema of the first derivative, but this really is more descriptive because it talks about the slope of f, which is like g double prime changing signs there, going if the slope is positive and then negative, or negative then positive. So that'll do it for B. Okay, for part C, I've redrawn, kind of did a rough sketch of this graph of f over here. It says find the average value of f from -5 to c. Well, here's -5 to c. An average value of a function, not the first time we've done this, it's the area of the function on the interval divided by the width of the interval. So the area is going to be the integral from -5 up to c of f t dt, and then we divide that by the width. Well, the way you get the width is you start at the right end and you say, okay, that's c, and then you subtract the left end and you get c plus 5, which makes sense because this is c units over here and 5 units over there, so the total distance is c plus 5 units. So we could take that whole thing and divide it by c plus 5, which of course would be the same as multiplying by 1 over c plus 5. So this is the other way you'll see it, from -5 up to c of f of t dt. Now, what we have to do is go get that integral. So we're going to be gobbling up area as we move over from -5. So this first part is a quarter of a circle, and that circle has a radius of 2. So that part there is 1/4 of a circle with a radius of 2. So it's 1/4 of pi 2 squared, which is 1/4 of 4 pi, which is pi. Now, it's important to realize that is negative because it's underneath the x-axis. We're moving from -5 over to c. So things underneath the x-axis are negative, above are positive. This next little region here is that little triangle there. His area is it's 1 unit wide and 2 units tall. So it is 1/2 of 1 times 2, which of course is 1 unit. And again, that's 1 unit, but it's negative because it's underneath the x-axis. So far we have negative pi plus -1. Now we get finally to some positive area. So we have this area above the x-axis, and that part right there is going to be 2 wide and 2 tall, and it's a triangle, so it's 1/2 of 2 times 2, which is positive 2. And then lastly, we have this region underneath this last thing over here. And we have this region underneath this thing over here, which is going to be 2 tall. It's 2 units tall, and it's c units wide. So we take 1/2 of 2 times c. And of course, those cancel, and we get c units there, and it's above the x-axis, so it's positive. So we can get our whole area, negative pi, -1, plus 2, plus c. That's our total area divided by c plus 5. Now, that's the average value of the function, and it says find c, so that... Okay, so my screen flipped out here, but basically we had to set this value equal to 1/2, and it said, you know, when is that average value going to equal 1/2? So we set the average value equal to 1/2. Cross multiply here, 2 times this stuff equals c plus 5 times 1. Distribute the 2 in there, and then bring your c over here, and bring your 2 over there, and bring your -2 pi over there, and you get 3 plus 2 pi. So that gets that's the value of c that makes the average value of the function equal to 1/2. Now for this last part, part D, we are looking at a function h is some new function that is f of x over 2, and it says find h prime of 6 in terms of c. So the first thing we do is just get a formula for h prime. And so h prime of x is simply f prime of x over 2. So you're taking the derivative of this thing. But then because this is a function of a function, f is acting on x over 2, we have to go back and take the derivative of what's inside. And the derivative of that x over 2, of course, is just 1/2. So h prime of 6, which is what they're asking us for, is f prime of 6 over 2 times 1/2, which of course is f prime of 3 times 1/2. So now our challenge becomes, what is the slope of f at 3? So if you come over to our graph here that I had drawn from the other side, they said c is bigger than 3. So that means 3 could be somewhere in here. Okay, so we're talking about the slope like maybe right there. So just pick the spot. It could be anywhere on this line. That's the point. It's a line. So the slope of this thing we need to get and put it in here for f prime of 3. Now notice the answer set, or the question says, find it in terms of c, which is a good thing because we can't get a numerical value for the slope because depending on where c is, this line slope, this line right here, this line slope is going to change. Think about it. If c was way out here, now the line would come down like that, and it would be a less steep slope. But we can just use the formula for slope. We know it's rise over run, and the rise is down 2, and the run is c. So the slope at 3 is down 2 and right c. So we can just substitute that in for f prime of 3, so we get negative 2 over c times 1/2. 2's cancel, and we get negative 1 over c. So that'll do it. There's our average, there's the derivative of h evaluated at 6 in terms of c.